Hello men and women of science, this is Mr. Cochrane here with our second video on writing names and formulas of ionic compounds. And this video focuses on using Roman numerals when writing names and formulas. We're hitting the basics, so here we go. When you watch this video, make sure that you have your notebook with you so that you can take good notes. Make sure that you have your two-sided periodic table with you as a reference for ion charges. And make sure you've watched the first video on names and formulas of ionic compounds. Before we begin, it might be helpful to review our ion charges. Group 1 metals, as we saw, are +1. Group 2 metals are +2. And Group 13 metals are 3+. Our non-metals, nitride and phosphide, are -3. Oxide, sulfide, and selenide are -2. And the halogens, fluoride, chloride, bromide, and iodide are -1. But we've skipped a lot of elements. How about these elements? These are transition metals and other metals. Well, here they are on the back of your periodic table. And you'll notice right away that many of these metals have more than one charge. These metals with more than one charge are the ones that need Roman numerals, and the Roman numerals tell us what charge is on the metal. We use Roman numerals to show the charge on metals that have multiple charges. We don't use Roman numerals on metals that don't have more than one charge. So with these metals, we just name them as we did before in the previous video. Since we'll be using Roman numerals to write names of these compounds, I thought it might be helpful to review Roman numerals 1 through 7. If you're not familiar with these, take a moment and write them into your notebooks. We're going to start by learning to write formulas for ionic compounds, and it's very similar to the process we've already followed, except this time the Roman numeral will tell us the charge on our metal cation. So go ahead and write the cation with its charge, and the anion with its charge, and then as before, you're going to add cations or anions until the total charges are equal. The net charge is 0. And we're going to then use subscripts to show how many of each ion we have in our formula. So let's get started. Our first example has iron 2 selenide. And remember that the Roman numeral tells us that this iron has a +2 charge. Selenide is Se with a -2 charge. These charges already add up to 0, so we're going to have one of each. And the formula of iron 2 selenide then is simply FeSe. For purposes of comparison, let's look at another iron selenide compound. This is iron 3 selenide. Remember that this Roman numeral tells us that the charge on this iron is 3+. Selenide still has a charge of 2-. The charges don't add up to 0. I have a charge of +3 and a charge of +2. So I need more of each ion to get the charges to balance out. Again, when the charges are different like this, you can ask yourself, what is the common charge of 3 and 2? For 3 and 2, the common charge is 6. So 2 of these iron ions and 3 of these selenide ions give me a charge of +6 and a charge of -6, and that charge adds up to 0. So the formula for iron 3 selenide is Fe2 Se3. So let's review what we've just looked at. Iron can have multiple charges, and so we need to indicate that by using a Roman numeral to tell us what the charge is. Iron with a +2 charge doesn't have the same formula as iron with a +3 charge, and so we have two different names, two different formulas. So let's get in some practice. Take a moment and write down these names and write the correct formulas for each compound. Remember, the Roman numeral tells us the charge on the metal. If you don't see a Roman numeral, that means it doesn't have more than one charge, and you'll need to look up the charge on the back of your periodic table. So pause the video and restart it after you've written your formulas and check to see if you've written the answers correctly. So here's the correct answers for these compounds. Make sure that your formulas are the same. If you're confused or you don't know where you may have gone wrong, go back and double check the charges on your ions. Make sure you look at the video again for samples or ask your teacher for some additional help. Next, we're going to get some practice writing names of ionic compounds that may or may not have Roman numerals in their name. That's for those transition metals or those other metals where it's not always clear. So what you want to do is identify the metal cation and determine if it needs a Roman numeral by looking to see if it has more than one charge. If it does need a Roman numeral, then we're just going to write down the cation and leave a space for that Roman numeral in parentheses. We're going to identify the anion that it's with and write its name, and then we're going to identify the charge on the cation by using the formula, remembering that the net charge on those ions will always add up to 0. I think that'll be clear when we look at some examples, so let's get going. Here is a copper fluoride compound, and copper is one of those transition metals, but does it have more than one charge? Let's look at the back of the periodic table and see. You'll find copper here on the periodic table, and you'll notice that copper does need a Roman numeral in its name as it has more than one charge. Go ahead and write down copper with parentheses next to it, and we can fill in our charge after we figure it out. Next, we're going to write down the name of our anion. This happens to be fluoride, and we're going to use these two fluorides to figure out what the charge on our copper is. You'll remember that fluoride has a charge of -1, two fluorides have a charge of -2, and our net charge needs to add up to 0. Therefore, our copper has to provide a charge of 2+, and since we have just one, the charge on this copper must be 2+. Therefore, we're going to put a Roman numeral 2 in our parentheses, and the name of this compound is copper 2 fluoride. Let's look at another example. Titanium and oxide. Does titanium need a Roman numeral? Well, we're going to have to check our periodic table to see. Let's go look at the back, and you'll notice that titanium does have multiple charges, therefore titanium needs a Roman numeral. So I'm going to write titanium and leave parentheses next to it and write down my anion, oxide, and then use these 3 oxides to figure out what the charge on these 2 titaniums would be. Remember, our net charge needs to be 0, and 3 oxides give me a charge of -6. Therefore, these 2 titaniums must give me a charge of +6. Since I have 2 titaniums, each one must have a charge of +3 to give me a net charge of +6. And our titanium ion then is the +3 ion. And in parentheses, then I'm going to put the Roman numeral 3, and the name of this compound is titanium 3 oxide. Our final example here has gallium and our polyatomic ion sulfite. Does gallium need a Roman numeral? It's one of our metals that are listed on the back. Let's go take a look. You'll see that gallium has only one charge listed. It's always 3+. Therefore, we don't need a Roman numeral in its name. So I'm just going to go ahead and write gallium without parentheses. I identify my anion sulfite, and this compound is simply called gallium sulfite. So take a moment and pause the video and write down these formulas, and then write down the correct names for these formulas using the methods you've just seen. When you restart the video, you can check to see if you've written the names correctly. Pause the video now. So here's the correct names for these formulas. Hopefully you've done them correctly. If you haven't, go back and double check your work. Make sure that you have the correct charges written for the ions, that the net charges add up to 0. If you still don't know where you're going wrong, take your work in and share it with your teacher. This is Mr. Cochrane signing off.